Okay. Hello, everyone. I think we have most of the participants joined now. So I'll kick off. Hello and welcome to this webinar, which is aimed at promoting the recently published standard recommendation SO55, which deals with the design and installation of solar PV for domestic dwellings. So just to deal with some housekeeping issues, firstly, just to remind everyone that this is being recorded. Also, you'll notice that video and microphone options are disabled due to the large number of participants we have this morning. However, you will see a Q&A dialogue box at the bottom of your screen. So if you have any questions, please pop them in there and we'll answer a number of them at the end. And yes, the recording will be made available after the event. So with us today, we have Piers Cullinane of the SEAI, who will give us some background into the market demand that prompted this standard, as well as providing us with details on available grants. We also have Tim Cooper, who is an independent consultant that was involved heavily in the drafting process. And Tim will provide us with an overview of the technical aspects of the document. And my name is Jonathan Clare. I'm a standards officer with NSAI. Just now, shortly, I'll be giving you a bit of a background into what NSAI does and how this standard was developed. So next slide, please. So NSAI is Ireland's official standards body. We are equivalent to BSI in the UK, DIN in Germany, or ANFOR in France, if any of them are familiar to you. We were established under the National Standards Authority of Ireland Act 1996, and we are accountable to the Minister for Enterprise, Trade and Employment. So there are 4 main divisions within NSAI: standards, certification, legal metrology, and National Metrology Laboratory. So in standards, we work with relevant stakeholders at national and international level to develop and publish global recognized standards. There are a number of core principles adhered to when developing standards, and 3 of those are transparency, openness, and consensus. So in terms of transparency, the development process is structured and robust, but it's also fully transparent and accessible, which is very important for a public body. Openness, meaning anyone can participate, be it through direct involvement in a committee or through the public consultation process. And then consensus is hugely vital. Basically, all views and objections are considered, and a demonstrated effort is made towards a resolution in all cases. So if the purpose of the NSAI Standards Division was to be reduced to just 2 words, it would probably be to connect and facilitate. So we facilitate Irish experts by providing them with a platform to input into the development of national and international standards. And these experts come from a wide range of stakeholders, including industry, academia, government bodies, etc. And NSAI also then connects to European and international standards organisations and puts forward Irish national positions and viewpoints to committees working in many varying areas like ICT, manufacturing, food, construction, etc. So to give you an idea of the wider world of standardization from an international point of view, NSAI is a member of a number of international standards organizations such as IEC, which deal with electricity and electrotechnical standards, ITU, which look after electronic communications, and ISO, which basically deal with everything else. Then in terms of Europe, we are members of CENLEC, which look after electricity and electrotechnical, ETSI for electronic communications, and SEN, who again deal with everything else. But what is important to note with respect to European standards is that as members of these organisations, NSAI is obliged to adopt each European standard as a national standard and then make it available to customers in Ireland. So this means that it's very important that Ireland monitors and participates in European standard development to ensure that the Irish viewpoints are put forward and captured within these documents. So to summarise, in terms of international and European work, NSAI facilitates national stakeholders and support engagement internationally through the formulation and agreement of national positions, which are then put forward. We also sometimes coordinate the work of these international committees through an Irish chair and or an Irish secretary. In terms of national work, NSAI policy is to prioritise the development of international standards. And this approach is consistent with government strategy to build an open market economy, which makes sense because if every country developed their own standards, a company who is trying to sell a product or provide a service across, for example, Europe, they would need to adhere to different standards for every single country they entered. However, sometimes there is no appropriate European standard, or a variation in national practices is apparent, or specific national conditions are present, like unique weather conditions. So these instances may provide scope for a national indigenous standard, such as an IS standard like IS 10101, national annexes to European or international standards which provide some additional national specific information, national forwards for European and international standards, or national standard recommendations such as SR 55. So how are standards such as SR 55 made? So at the beginning, basically any relevant stakeholder can propose a new work item, and NSAI will then assess this proposal in consultation with relevant stakeholders from the industry. If approved by the NSAI board, the work will then be assigned to either an existing standards committee, or a new committee will be formed with interested stakeholders from that sector. The committee then develops this standard through a consultative and consensus-based process. Eventually then a draft is created and submitted for public inquiry. It's at this stage that any member of the public can review and provide comments on the document, which are then fed back into the standards committee, who review these comments and improve the draft where appropriate. Finally, then the revision is validated and published and made available in the standard store. And every 3 to 5 years, every standard is reviewed and revised as appropriate. So that is basically how SR 55 came to be. Originally, it was proposed on the back of industry demand, but it also is in support of government policy, specifically Action 138 of the Climate Action Plan 2021. So we had strong industry stakeholder participation, which greatly helped the development process and resulted in a document that we hope benefits installers, designers, and ultimately homeowners. So now I'm going to hand you over to Pierce Cullinane of the SEAI. Pierce has a wide range of experience in the area of renewable energy, including program management and energy consultancy. And since 2019, he has been working at SEAI in the solar PV and domestic retrofit grant programs. And he was a key member of the solar panel committee. So the floor is yours, Pierce. Thank you.
Thanks, John. So my name is Pierce Cullinan. I work with SEAI on the grant schemes, previously solar PV, currently working on a one-stop shop. Go to the next slide. So from SEAI's point of view, why do we need an SR 55? So in 2018, SEAI grant scheme for domestic PV started. It's up to 6 kilowatts peak. That's the level covered by the standard. You see it's very popular. You can see the growth on this slide. In 2018, we had 71 installs when we started. This year, we expect over 6,000. And in 2021, we had 16.3 megawatts installed just on domestic. And this growth includes the shutdown with COVID. So you can see it's a very popular scheme for homeowners, industry, and government. And currently, we have 182 companies and 140 installers registered with the SEAI PV scheme. So this growth is expected to continue. The Climate Action Plan has a big role outlined for PV. The microgeneration support scheme is coming online. So in 2019, we initiated a process to develop a standard for domestic PV. Industry was growing, installers wanted clarity in what was required. And structural considerations, wind loading, safety, DC wiring. There was no national standard at the time. There was a code of practice that SEAI developed. This code of practice, it referenced the old SR 50, the old SR that covered thermal. It wasn't really relevant for solar PV. So an updated SR was needed. The SR process was started with NSAI to include installers, electricians, structural experts, government, technical panel, as outlined by Jonathan. So we developed a useful SR 55. So go to the next slide. Sorry, microphone up there. That last slide, you can see this shows total installed PV capacity in Ireland. From that last slide, we could see for domestic PV alone in 2021, we had 16 megawatts. There's 136 totally in Ireland. This also covers a community, industry, commercial and agricultural PV installs. So this is just to show you the total PV industry is growing. Go to the next slide. So there's microgeneration support schemes. A lot of you heard about that. That's coming online. It's expected before the end of the year. With this new scheme, domestic applicants will be eligible to receive a clean export guarantee for any export electricity from renewable sources. PV will be 95% of that. Microgeneration includes small wind, hydro, but 95% is expected to be wind. This tariff will be paid at a competitive market rate from the electricity supplier, and the clean export guarantee will be available to both new and existing microgenerators. And this new microgeneration scheme would support businesses, farms, community buildings, and schools, sports clubs, generating up to 5.9 kilowatts. They'll be eligible for an SEAI grant, the same as with this domestic customers. And then larger projects from 6 kilowatts to 50 kilowatts, they'll be eligible for a clean export premium of 13.5 cents in 2022. So go to the next slide. So there's a few changes with the SEAI grants with this new microgeneration scheme. They removed the minimum C3 BR requirement to qualify for a solar PV grant. This is after the works were done. Yeah, note a BR is still needed, but you don't need to meet a C3. That previously eliminated a large percentage of the market, but that's gone now. There's a change in the minimum year of construction. It used to be previous to 2011 was eligible, but now it's before 2020, all homes. There's no battery grant that has been removed with the microgeneration support scheme. And all applicants are now eligible up to 4 kilowatts. Previously, anything over 2 kilowatts peak, you had to have a battery included. And there's a maximum grant of 2,400. So you can see that with the increased demand, homeowners are used to technology, energy costs are rising fast. So with the recent events in Ukraine, there's a big market, a lot of interest in solar PV. So there's long-term support by the government, and there's grants there and funding. And now we have an agreed standard. The future's bright for solar PV. So next, I'll hand you over to Tim Cooper. Tim was a consultant in Ireland. He's been doing installs on solar projects from the start of that grant. He's done a lot of consultancy work with SEAI. He was involved in drafting the original code of practice. So he was the technical lead on developing this standard. So I'll hand over to Tim.
Thank you, Pierce. My name is Tim Cooper. I'm an engineer. I've been involved in the energy industry since the late 1960s, when I worked as a student on ESB's Turlock Hill pump storage project in County Wicklow. Next slide, please. In the early 1990s, I spent some time in Japan studying their then well-developed grid-connected domestic PV technology, and later came back to Ireland and commissioned the first ever ESB EN 50438 compliant grid-connected PV system in the Green Building in Temple Bar. Just to explain how times have changed, at that time I had to obtain a license to sell electricity. I became the first privately operated electricity supplier in the country. I also had to get consent from CER to construct and operate an electricity generating station before I could connect. And on the technical side, I had to create the first ever EN 50438 Irish settings control and protection system, which I did in collaboration with Fronius, and then bring in a team of UK engineers, commissioning engineers to witness test the entire operation before I could connect. And today you send in an NC6, how life has changed. Next slide, please. So there it is. That's the witness testing. That's the UK commissioning engineer over here. He normally commissioned full-scale power stations, but he brought his team and his equipment over to commission my 3.2 kilowatt PV system. The room was so small that the witnesses couldn't fit in, so we had to have a sort of a shuttle system where they came in and witnessed from time to time. Next slide, please. In October 2019, I teamed up with KSN to provide technical secretary expert service for SEAI for the development of a solar PV standard. Next slide, please. The brief was to build it on existing European standards, the guidance already available in the SEAI technical standards specifications document, and the UK MCS publications. Next slide, please. The scope, and one of the things I learned while drafting this document is that when you're reading standards, you focus on the scope first to see what it applies to. And in this case, it applies to grid-connected solar PV, single phase only, crystalline silicon and thin film standard PV modules, but doesn't apply to BIPV, built-in PV, or wall or ground-mounted systems. Next slide, please. So what I did was I got my hands on all relevant European, UK, and Irish standards, plus some relevant US and Australian material, all done with the help of SEAI and NSAI. And I tried to extract from that material that was relevant and going to be useful to installers in Ireland. And the documents I read and we have referred to, fell into these four categories. The first one was relating to the manufacturing and testing of components. The second was standards relating to design of support systems. And then there were a number of others relating to designing, installation, and commissioning. And finally, others such as ESB planning, etc. Next slide, please. We added other guidance for which we hadn't got reference material, and because it just isn't out there. And they covered such things as optimization of location and orientation, calculation of system output, and performance optimization, all very important. Next slide, please. So the first group, which are the standards relating to manufacturing and testing of components, they're all there, they're all available, they're very readable if you have a lot of time. But I don't think most installers do need to read them. They need to know about them so that they can check to see if the components and equipment they're using are compliant. So that's intended as a checklist, really, to see if there is evidence there that the equipment and materials they're using is compliant with the relevant standards, and it's usually done by appropriate certification. Next slide, please. Then there is the standards relating to design of the support systems, and they're covered under the documents which are more commonly known as the Eurocodes. And they provide guidance about how to calculate the forces involved or forces created by self-weight, wind and snow load on the solar PV modules themselves. And that's described in SR55, and there's a detailed example in there for those to follow. It also describes the standards for designing fixings to the roof structures. Next slide, please. And then there are these three major standards documents that we've referred to. There's IS 10101, which is the Bible in this industry. It covers all the AC side of the systems comprehensively, and some of the DC side. IEC 62548 essentially covers all the DC side together with some earthing and the like. So those two documents are key, and I believe most installers should have those and understand them. And then 62446 is testing, certification and maintenance of installed systems. I believe a very useful document, and it provides, most importantly, the standard forms that can be followed when you're testing, commissioning, and then carrying out periodic retesting and maintenance. Next slide, please. The other guidance in there, it's more about efficiency and performance of the system. It looks at location, output, performance optimization. And the intention there was to draw attention to the importance of the efficiency of completed systems. And that's because the industry and the professions go into huge lengths and great efforts to maximize the efficiency of their buildings and of the PV modules and inverters. And all of that is to no avail if the PV system itself is not designed to operate efficiently. And for that to be done, I believe you need to compare the as-built output with what is the optimum output, and to determine how much of that output will be used effectively on site. And that needs to be done before installation, in consultation with the customers. Bearing in mind that the main objective here is set to comply with the climate action plan, in other words, to reduce CO2 emissions. And one of those is to offset embedded carbon. So it's important that these systems are efficient. And the other is to enable users to use PV output in place of coal, oil, and gas. Next slide, please. So I'm going to stop there. But before leaving you, I'd just like to thank the team that I worked with, without whom there would be no SR55. KSN, who were my partners, and they supported me from start to finish throughout a long and sometimes complex and difficult job. SEAI were equally helpful and supportive. The NSAI team gave the badly needed guidance to me for drafting a document in compliance with the relevant guidelines and standards. Their patience and support was tremendous. The Department of Housing, Local Government and Heritage also gave a great deal of very valuable support and a lot of their time. And perhaps most importantly, the chair and the members of the Solar Panel Committee. Again, they put in a lot of time. They gave me a lot of guidance, both at committees and outside, and lots of support that was needed when times were tough. The PV industry was there at all times to give me advice and assistance. And finally, there were the members of the public who took part in the public consultation, without whom we wouldn't have been able to address all the issues that were identified.